In this video, we're going to look at titration, and titration is a form of stoichiometry. The stoichiometry steps are here. I've mentioned them in several other videos, so please feel free to look at those if you're not sure what the steps are. In this example, we've got the problem is, what is the concentration of sulfurous acid? So we're being told that 10 milliliter samples of sulfurous acid are titrated. So these are in the Erlenmeyer flask, are titrated with a standard 0.110 mole per liter solution of sodium hydroxide. Phenolphthalein indicator, which changes from colorless to pink at the end point of the reaction, is used to detect the equivalence point. Now, all of this information is contained in a little data table, and in the first trial, they had an initial volume of 0.1 milliliters, but the trial ended when the phenolphthalein turned dark pink, and it was 16.1 milliliters because I subtract these two numbers. So in the next trial, 29.5 minus 16.2 is 13.3 milliliters. This is going to be 13.4 milliliters, and this is going to be 13.2 milliliters. And so we've got our volume of sodium hydroxide will be determined from this. Now this sample is dark pink. These are all light pink. This trial, they went too far in. So we will use these three trials to find the average volume of sodium hydroxide added. But before I get into that, we need a reaction. They've got sulfurous acid, which is H2SO3AQ, reacting with sodium hydroxide, and it will produce water and sodium sulfite. So there are going to be two waters, and there are going to be two sodium hydroxides. So this is our reaction. We know we have 10 milliliters, so the volume of sulfurous acid is 10.00 milliliters, and that the sodium hydroxide has a concentration of 0.110 mole per liter. The volume of sodium hydroxide, though, is 13.3 milliliters plus 13.4 milliliters plus 13.2 milliliters, and we need to divide those all by 3. This is going to give us, in our calculator, 13.3 milliliters. If you get a volume that's bigger than any of the trials, you've done this math incorrectly. So you just be aware, if this ended up being like 20 point something, then you've just done your math wrong and you'll get the wrong answer. Now, I've got enough information to find the number of moles of sodium hydroxide, right? I've got a concentration and a volume. So the number of moles of sodium hydroxide equals C times V. So it's going to be 0.110 mole per liter, the concentration of sodium hydroxide, times the volume, 13.3 milliliters of sodium hydroxide. Now in this titration, I'm going to use the milliliters. I won't bother converting it to liters. The reason is that I'm going to be dividing by milliliters again. It cancels out my millis. So I've got 13.3 times 0.110, and that gives me 1.463, but I'll just write down 1.46 millimole of sodium hydroxide. But what I want is the concentration of sulfurous acid. So the concentration of sulfurous acid will be determined using its chemical amount. So I take 1.46 millimole of sodium hydroxide. I want to get rid of sodium hydroxides and be left with sulfurous acid. And I get 1 sulfurous acid for 2 sodium hydroxides. So that gives me 0.732 millimole. I've rounded it off. My calculator says 0.7315. But I keep that in my calculator. Finally, I can calculate the concentration of sulfurous acid by taking the number of moles divided by the volume. So I've got 0.732 millimole divided by the volume of sulfurous acid was 10.00 milliliters. And in this case, my millis cancel out, leaving me with mole per liter. So I'm going to get 0.0732 mole per liter, or This is 73.2 millimole per liter. So you just multiply it by 1,000 to get that. Okay, so that's how you do titration calculation. Hopefully that helps you. You're always going to need to have this data table or an average volume. You're going to have a reaction, organize your information, find the chemical amount, use the coefficients to get the chemical amount, and then calculate your final concentration.